little geometry review for you out there in Introduction to Calculus Land. Here, Ms. Stewart, how are you doing?
I'm wonderful. How are you?
And here I have drawn the box. It has a base of 2x and a depth of x and a height of y. And the problem asks me to write an equation for the surface area of this box, rectangular prism, in terms of x. And I'm given the volume right here. The volume of this thing is 50 cubic inches. Means that's like how much water I could pour in here, or I don't know, what else would you pour in your box?
Popcorn.
Popcorn. I fill my box with popcorn at home all the time.
Excellent.
Do that? Yeah.
Don't you mean your rectangular prism?
My rectangular prism. I have one with popcorn right over there in the corner here. So I want to write an equation for the surface area of this thing in terms of x. Well, what is the surface area of this thing? I mean, surface area, to me, the term describes exactly what it is. It is, in fact, the area of all of the surfaces of this thing. Well, how many surfaces are there on a rectangular prism? There's 6. Unless, of course, if it was an open top, it would only be 5. This guy has 6. It has a front that is 2x by y. I'm going to keep track of this. So my surface area, I'm just going to call it A for short, has a front 2xy. 2x times y. It has the same side behind it, also 2xy. It has this side right here, which is xy. One just like it on the other side, another xy. xy plus xy. It's 4 sides so far. What am I missing, Ms. Stewart?
I think the bottom and the top.
Oh, yeah. So the bottom, 2x times x, also known as 2x squared. And the top is also 2x squared. You got that whole thing?
I do.
That's a big surface area.
That's a lot of surface going on.
Well, the good news is I have a lot of like terms which I can add up. 2xy plus 2xy, that's 4xy. Another xy, that's 5xy. 6xy. My area is 6xy. Plus 2x squared plus 2x squared, that is 4x squared, is the area of the thing. Well, that's great. I want the area, the surface area, though, in terms of x. So somehow I need to get rid of this y. Any other information I have here?
Well, I'm going to scan this back over.
Yes.
Ah.
I do have the volume. Well, what is the volume equation? It's length times width times height, or base times, or the area of the base, I guess I could say, times the height of it. Anyway, 2x times x times y. Let's see, that's 2x squared y. That is the volume, and I can even do better than that. I know what the volume is. The volume is 50 cubic inches, 2x squared y. I want to get rid of y over here. So what if I solve this for y? Divide each side by 2x squared, so I've got
I see where you're going with this.
y equals, yes, thank you very much, 50 divided by 2x squared. I think I can simplify that a little bit. That's 25 over x squared. Is that working for you, Ms. Stewart?
It's working for me, absolutely.
Okay. So this I've solved for y. I have y over there. I can just put that in for y, and I have my area equals, I think I'm getting pretty close to being done here.
I think so too.
25 over x squared plus 4x squared. We can simplify that even a little bit more.
Sure.
This is like really over 1. I have an x on top, x squared on the bottom, get rid of one of those x's. 6 times 25, can you do that in your head there?
I think it's 150, isn't
That's
it?
very good. 150, and what am I left with on the bottom?
An x.
1x, and I still have that 4x squared. So there we go. That is my surface area, or area, okay, in terms of x.
Beautiful.
Thanks, Ms. Stewart.
Here we have a box that might look familiar to you.
I think that's the same
I
box.
think it is. Rectangular prism.
Rectangular prism.
But now we're going at it kind of in a different way. Instead of knowing the volume, I'm giving you the surface area. That's a big box.
Oh, that's enormous.
If I'm going to be wrapping this with paper, let's say, I would need 100 square meters of wrapping paper. Start shopping now. Okay, so same thing. We want to write an equation for the volume of this box now in terms of x. All right, so volume of any rectangular prism is the area of the base, which is 2x squared times the height. So my volume is going to be 2x squared y. So far, so good?
It's great.
Hey, aren't I done? Don't I just want an equation for the volume of the box?
That is an equation for volume, only I think you have an extra variable in there, Ms. Stewart.
I have that y in there, and I just want this in terms of x. Now, we've done this before. Remember when we were doing the cone problems, and we wanted to get rid of the radius and the height? So we've done this before, so it's kind of the same thing. So let's go back and see how I can use this information to come up with an expression for y, so I can replace that y with something with x's in it. How's that sound?
Sounds good.
Okay, surface area. Well, we just went through this. The surface area of this or any rectangular box is adding up all the surfaces. So we have, again, the front, which is 2x by y, and I have 2 of those. Can I just do this?
Sure.
All
Go
right,
for it.
since we already did this. We've got this side, which has an area of x, y, and I've got 2 of those. Then I have the top and the bottom, 2 of those, and that area is 2x squared. How am I doing?
That's great.
And that equals the surface area, and I know the surface area to be 100. All right, let's just clean this up a little bit. This is 4xy plus another 2xy, that's a 6xy, plus 4x squared.
So that's the exact same equation that you got in the last problem, except this time you know the surface area. Got it. All right. So yeah, I'm with you, Stuart.
So keep your eye on what you're doing here. I want an expression that I can use to substitute in for y there. So I basically want to solve for y here. Just going to do a little algebra to get y by itself here. So let's subtract 4x squared from both sides. 100 minus 4x squared equals 6xy. And again, a little more algebra. I'm just going to divide both sides by 6x. We're assuming, of course, that x is not equal to 0 here. That's why I can do that. I'm running out of room, but can you see that okay?
Yep, I gotcha.
All right. Now, I think I can kind of simplify that a little bit, but I'm just going to throw it on in because I already have an expression for y in terms of x. So I'm going to come back here to my volume problem and substitute that y with 100 minus 4x squared over 6x. Now, can I simplify that? I'm pretty sure I can. Let's do what you did. I liked that little throwing that over 1. Now, you can think of this a couple ways. You know what I'm going to do is I'm going to factor. Well, you know what? I'm not even going to bother factoring because, look, I've got that too. So let's take that back. Top times the top, bottom times the bottom. Let's divide things out. I think that 2 divides nicely with that 6. That x squared divides nicely with this x. That was much easier.
Oh, yeah.
All right, so I've got an x left here times what I have here. So this sometimes gets a little confusing. I'm multiplying x by that whole expression, so it's 100x minus x times 4x squared, so that's minus 4x cubed. Bottom, the denominator is 1 times 3, which is 3. Then I always look, is there anything further I can simplify?
That looks good.
And I think I'm done. And there is my expression, or sorry, my equation for volume in terms of x.
I'm doing one more of these, Ms. Stewart.
I think that's a great idea.
And hopefully you'll see they're really all the same. It really doesn't, it doesn't even matter like what shape we're dealing with. They're always something to do with the volume, something to do with the surface area. You either get the volume or the surface area, and then you have to like write the equation for the other one in terms of one variable. but it's always basically the same thing. In this case, it's a cylinder, and I'm given the volume, and I'm asked to write an equation for the surface area of the thing. I could have said, here's the surface area, write an equation for the volume of the thing in terms of one variable, but I'm asking it this way.
Excellent. And you're just, in terms of R, you could have asked us to write it in terms of H. It doesn't matter.
Absolutely. Absolutely.
Wonderful.
So the first thing I'm going to do is I'm just going to write, I have to always think this through. I'm going to write the equation for the volume of a cylinder. It's just the area of the base. I'm going to make a note of it here. Volume. Area of the base, that's a circle, of course. Area of a circle. Remember that one, Ms. Stewart?
Pi r squared.
That's fabulous. Pi r squared times the height of the thing. So that's my volume equation, r squared h. In this case, I happen to know the volume. It tells me the volume is 300, so I'm just going to fill that in. 300 equals pi r squared h. Looking good?
Looking good.
And now I'm going to need, it wants the equation for surface area, so I need the surface area equation. Again, I just add up all the surface areas. Can I just say A for surface area?
Yes, you may.
Area, surface area, you get it?
I do get it.
Yeah, thanks. So my cylinder has a bottom to it. Again, that's a circle. The area of the bottom, pi r squared. Does it have a top?
Yes, it does.
It does. Sometimes we give you these problems with open tops, in which case you wouldn't write anything down from the top. This guy does have a top, so that's another circle, pi r squared. And then it has a side. Yeah, that's always tricky. What is this side? If I like cut the thing, I don't know if this is gonna work, but can you imagine if I like sliced my tin can here and kind of unwrapped it? What would it be? What shape would that be?
Well, when you open a soup can label, don't you have a rectangle?
Yes, that would be very good. That would be a rectangle, and I'm kind of roughly drawing my unwrapped rectangle there. Is that working for you?
It's working.
The length of it, this dimension right here, is the height of the cylinder. I'll call this h. Am I still on the camera here?
Yes, you are.
That's fabulous. What is this dimension, the length of it? Well, what are you thinking, Ms. Stewart?
I'm thinking, well, if you're opening that label, that's exactly right, the circumference.
And how do you find the circumference of a circle?
2 pi r.
Terrific. Well, the dimension of this rectangle, which is really the side of this can, the cylindrical thing, is really the circumference, 2 pi r, times the height. So, back to my area. I've got the top, or the bottom, doesn't matter, the bottom plus the top plus the side, which is 2 pi r h. That is my area.
Very cool.
Terrific. So I want it in terms of r. So what's the variable I'm getting rid of here?
I think you're getting rid of that h.
Getting rid of h. Fabulous. So here, I'm going to go back to my other equation. If I can get h by itself here, that doesn't look too bad. I'll divide by pi r squared. Pi r squared. That's h. I think I'm almost there.
I think you're almost done.
Just going to stick that in for h. And I have my area. I'm going to add these up while I'm at it. Pi r squared plus pi r squared. It's 2 pi r squared plus 2 pi r. Instead of writing h, I'm going to write 300 over pi r squared.
Beautiful.
A little simplifying action here. Let's see. I have a pi upstairs, pi downstairs, 1 r upstairs, get rid of 1 r there, and I'm going to multiply that 2. And finally, oh, I'm dangerously close to the end, Stuart.
It's very exciting.
Yeah. 2 times 300, thanks. 600, and what do I have left on the bottom?
I think you just got that r.
I just have 1 r. And that is my area equation.
In terms of r. Oh, perfect.